that I've been contributing to over the last 5 years are BioPython and the Galaxy project. I've wrapped quite a few tools that we're using locally, and I maintain a Galaxy locally. So, slightly different perspective.
Okay, so I'm Jean Peccoud, I work at Virginia Tech in the US. My group, we have managed to have 2 grants from the National Science Foundation to start software development projects. And I have, one was a fairly large grant, the other one was a very small grant. I tried several times to get additional round of fundings to keep, the development of the software, and got very little traction with that. And the program directors even told me that they were absolutely not interested in, maintaining software. They were pretty blunt about it. So the funding strategy right now for the open source software is really, I set up a corporate structure that provides services around the open source platform in terms of maintenance contract or development of content or consulting job. That hopefully, the plan is that some of this will go back to further development. Another plan is also to apply for SBIR grants, which are small business grants that are available in the US, and which hopefully will be a little bit more receptive to developing tools, whereas the research grants are not really meant to do that. That's the plan. I don't know if it's going to work.
Scott?
Scott Markel. I work at a software company called Accelrys. Lead a small biology team, and we build component collections for a product called Pipeline Pilot that's used for creating scientific workflows, so very similar to Taverna. And we make heavy use of open source programs and libraries because that's the functionality that my customers want.
So I'm Sean Eddy. The software that has been developed by me and to some extent my lab, I'd say primarily has been a hobby, a side project, and we've sort of designed it that way so that if our funding ever got taken away, we would still continue to do it. That sort of limits the scope of what we try to take on. But the second thing I'd say is that our stuff, we also consider it to be a platform, so we spin projects off of it. So we feel very good about our position underneath of PFAM and RFAM and the stuff that's done at the Sanger Center and the EBI, and help them with getting their funding. There's also been spin-outs within our group. We'll spin out a side research project that uses Hammer as a platform, for instance, or Inferno as a platform. So the aim itself will be sort of separable and funded separately, but relies on the software as a platform. And the third thing that I'd say about where we get our funding is that I have the very great fortune of working in the United States for the Howard Hughes Medical Institute. I'm actually not even eligible for federal funding anymore because of my position at Janelia Farm, the first intramural research center that Hughes has built. But Hughes has a very distinct funding strategy from federal funding. They fund people, not projects. And so I have to justify myself every 5 years retrospectively by my impact on the scientific community. So not just papers, but what have you done that's actually made an impact? And I have to convince a panel of reviewers of that impact. And they're quite broad-minded about their definition of impact. And they deliberately, somewhat scarily, define what they call the deletion test. If I were to be deleted from the scientific community, would there be a phenotype that could be observed? And if there's no phenotype, therefore I have no impact. And so they are trying to judge a research program, any Hughes investigator, there's about 350 of us in the US, any Hughes investigator is being judged to that standard by impact. And so that means that I can actually get up and say, part of our portfolio includes our open source development work, and here's how it's having an impact on the scientific community.
So I'm Carole Goble, and I'm a professor of computer science. So I'm a classical European researcher who's getting grants in order to be able to keep things going. And I currently have 19 postdocs, and that's about 2 million a year, which is why I'm grey. If my hairdresser didn't come and colour me every 4 weeks. So what do? I have a four-way sort of matrix. I have projects that I have to get funding for. I have products that cut across those projects. And I have skills in the team that have different aspects associated with projects and the products. And then, because I'm a computer scientist, I'm supposed to do some research in order to be able to avoid the deletion test. And that has to be juggled. So for actually keeping the infrastructure going, to keep the software going, I have to really go to users. So I have projects to e-infrastructure projects, usually at the European level in, at the moment, biodiversity, heliophysics, document preservation from libraries, astronomy, systems biology, and traditional bioinformatics, and social science. You'll notice that not many of those are to do with mainstream biology, and that's because it's infrastructure. And out of those, I can slice across in order to be able to keep the products going whilst delivering for the projects. So that's what I end up doing. What's my biggest headache? Human resources. Because, of course, what I'm doing is, and I know this is being videoed, what the hell, is I'm actually doing institutional fraud. Because I'm moving things around against different grants at different times. Everybody does it. It sends the auditors apeshit, but that's what I do.
Great, thanks guys. So there you go, Wynn. I was going to say ask for questions, but Wynn's already ready to ask questions, so go for it.
All right, so I have a question because I suffer this pain every day, and I want to know what you guys have to say about this. We've all had wonderful developers to work with, or have spearheaded projects ourselves, and you know, the ultimate developer loves to develop and work in the community, particularly open source developer. And I've protected myself by being part of FOSS for eons, and I love this environment. But there's one thing that has to come, as you say, it's funding. What do you think the importance is of classical publication of your software work to its role in ensuring continued funding for the projects that will follow?
Yeah, just speak up whoever wants to talk first.
It's not aimed at Brad, I swear.
Yeah, that's personally to say I should write some more papers, so that's I'm not answering.
We were recently reviewed as a department within my institute, which is the Computational Sciences Group, and we were able to get software listed as an outcome, a deliverable that the group was making, something that has impact. But nevertheless, papers are still highly valued, and we are expected to produce papers.
Does like the BioPython paper help you?
That definitely helps me.
Yeah.
Very highly cited. It's my
Yeah.
most highly cited.
So it depends, is the answer. If so let's take it from the individual career point of view. So if I am one of my software engineers, for them the papers aren't important because they're more interested in who is using my software, what are my skills, because that's the sort of thing that will get them the next job or the impact. For the informaticians or the researchers, then the papers absolutely are what counts. And although there is lip service towards software and downloads and so on, when it comes down to it, it's the papers that really cut the mustard. And you can put as much as you like about impact through software, but really people, they always fall back on the papers. And we end up writing papers where the software engineers are on the papers, but they wrote the software, but the papers are written by somebody else. So we kind of have, make sure that there's credit distributed across the papers as well. That's another way of handling it. For me, not a single one of my informatics papers count for the UK REF. So REF is a thing where we are assessed every 5 years in the UK. It's a big deal. It's directly related to how much income universities will be. And I'm in computer science, and not a single one of my informatics papers counts, despite the fact that some of them have 700 citations. Don't mean shit.
Is that because of the journal they're in?
Because they're in bioinformatics.
And not computer science?
Not computer science. They have to be in the journal that nobody reads with the impact factor of bugger all. but really good computer science rigor. She said bitterly.
So we use papers, so there's some papers that we publish that are sort of updates on PFAM or what have you. But for a lot of the serious stuff we do, we write the papers because it's actually useful to write the papers. In the sense that I find that software development, when I'm in that mode, has a tendency to sort of go and go and go, and you're like, just, you know, when have I actually proven to myself that I've hit a milestone and accomplished something? So I'll often start beating on people in the lab or myself saying, okay, have we actually proven this? Have we actually got this algorithm working? Because to prove it to yourself, you're going to have to do a bunch of experiments. Convince yourself, convince me, and the sort of rigor of writing that paper is the sort of thing we use is that stick to beat people with. It's like prove that you've actually done it. And then, you know, once you've proven it to yourself, you finish the paper, you get it out there. And it's sort of a living, you know, you've actually made a contribution. So that, I think, for me, it's also sort of a nice, positive way to think about the publication process. You know, sort of this is a milestone that we've actually reached, and we've proven that we've reached it.
Thank you. People have follow-ups on that or more questions?
So I'm struck by the fact that the panel is made up of people who either have a significant, well, have in some cases both a large amount of money behind them or a significant organisation with continual funding. Is part of the message of the makeup of the panel that actually doing this successfully requires critical mass, and that doing it on a small scale is not worthwhile?
Not deliberately.
No pressure.
So I would I've had this discussion with a lot of people, young people especially, who go, well, it's easy for you to say X because you're a Hughes investigator and you have a pile of money. And I say this confuses cause and effect. I started as a postdoc. I did this because I have strong beliefs about open source and impact on stuff. And as a result of that, Hughes, which is in the business of identifying things that they think make strong impact on science, fortunately decided to make me a Hughes investigator. And so I think that actually that's a statement that's sort of the opposite. It's a statement that the funding, at least there exists a funding agency which is capable of recognizing open source development and its impact on science, and then say, we want more of that, we want you to establish a lab that's doing that.
So from the commercial perspective, thinking through the different kinds of open source tools that we leverage, I can think of one individual who helped me out quite a bit. It was André Blavier from France, had done a port of MBOS to Windows well before Peter and Alan got around to it, and saved my life because we were trying to have our product available both on Windows and Linux. So I think there's a really good example of a single individual who definitely helped out my customers.
So I would say I run a big team, but they're all doing different things. And one of the most successful things I built is a systems biology sharing platform, which is really 3 people. But it was partnered with lots of scientists. And I think, referring back to yesterday's talk, about being driven by the science is important, right? So that's the way you get the impact from. And so it's not the critical mass of the engineers, it's the critical mass of the kind of amplification of what those engineers are doing with the scientists.
I spend some of my time in industry and some of my time in academia, and you know, there is a big difference between writing a prototype that, you know, I'm putting the source code somewhere and, you know, in a state where it's going to be very difficult for a lot of people to use it, and bringing the software to a point where it can actually be used by people who are not software developers. And, you know, between the prototyping and the finished product, you know, the cost of making the finished products may be 10 times the cost of doing the prototype. You know, and that comes with, you know, developing nice user interfaces, the right documentation, training material, outreach to the community, and that kind of things. So it a little bit depends on, you know, what is your target audience, and things like this. I mean, if you're going after people who are not developers, as opposed to just developing a library that, you know, that is targeting, you know, a smaller number of people, then the cost of making usable software can escalate pretty quickly.
Related to that, your question about critical mass. Many important bioinformatics projects start as one-person projects. And if they are sustained over the long term, it's usually because they have achieved critical mass through a community of developers or some funding to keep critical mass. Or occasionally the crazy insane people that just do it as a hobby. And that's partly why I'm still doing Python. It is a mixture of a hobby and work time. And that is partly how I got my job as well. So it does pay dividends at a personal level.
So I've got Francis hand.
I want to add that there is definitely the funding agencies in the various countries are very different models, and they have different panels that allows you to apply for small grants and large grants, for resource grants, and there's a whole range. But there's also, in my country, in Canada, I've noticed that we had to push one of our funding agencies to actually fund small projects. Genome Canada, if it was less than $1 million, they wouldn't even look at it. But we had to sort of pound on their heads and say, well, we only need like 1 or 2 developers, and don't pay them $1 million to get either things initiated or supported to do help desk and whatsoever. And then if LinkedIn was here, he'd talk about Gmod, and Gmod is running on less than $100K a year, and it's having a big impact on a lot of projects. And it's actually coming to an end, and it's actually looking for a home right now. So if somebody has a home for Gmod, I'd like to put that plug in there. But it's a small scale cost-wise, but it has a very big impact community-wise.
Thomas.
So following on from that, and maybe this is something that's worth a straw poll, is if one were being internationally flexible, what country should one head to run a project, to run the sort of projects we're talking about here?
Farmers. I don't know, so what do you guys think? I don't know if you have any opinion on other countries behind your own.
You talk about funding access.
Yeah. Or specifically the question of where is the funding climate most favourable to the kind of small to medium grants for infrastructure projects that a lot of us are potentially looking for.
So Australia's quite good right now.
I would actually say Australia has two granting agencies specifically for bid software development.
Exactly.
You cannot use your grant funds to develop software. So the only way that we sort of get around it is try and get onto the support for other medical grants or whatever.
Okay, sorry, I've had completely the opposite. Some other people.
Australia has had in the last few years this big round of infrastructure funding, but officially there was this big one-off super science thing that will not continue.
Okay, so it used to be good.
Yeah. that's not for people, that's for hardware.
No, that's for software as well, but not for maintenance of software.
No.
It's for software. Pretty much infrastructure.
Don't go to Australia, so we just
Well,
go listen to Carole and go to Australia.
We should have gone to Australia some years ago by the sounds of it. But in the UK, we're working, and we've nearly succeeded in at the funding council level, which is where you have to really fight for these things, in rebadging software as capital investment. And you think, well, why does that make any difference? It makes a huge difference, because kit is capital investment, building is capital investment, and governments like to give capital investments, but don't like to give recurrent, because that's continuous. But if you can badge software as capital, and you can kind of purchase it, you're purchasing it from a provider who then have people to provide it, then you've released a whole bunch of funds. And so that may potentially, Thomas, mean that in the future there may be different ways of getting infrastructure which is software funded in a way that we never were able to before, because it's taken, I've been on lots of committees persuading government that software is infrastructure, just like networks are infrastructure and computers are infrastructure, and we've nearly won. So that's an optimistic
What was it before it was infrastructure?
It wasn't infrastructure. It was woo-woo. It was free stuff. It was I don't know. Well, I don't think people thought about it.
Okay.
They just assumed it was there.
Yeah.
But they didn't think of it. It's because you can't. It doesn't have a. You can't cut a ribbon at some software. You can cut a ribbon at a big machine that goes ping in a fancy box with a label on it, right? So yeah, that's
Okay.
that's a big thing.
So you need to ship software in boxes again, right? Is that
Absolutely. There's a very famous story of the first simulators on programs on planes. And planes, its weight is very important. And so the quality assurance people turn up and say, well, you've got some software on it. Where is it, and how much does it weigh? And the guy who told me this said, so we couldn't persuade them that it was like software. So he took them to punch cards, shows you how long ago this was, punch cards. And he said, this is the software. And they went, see, we knew it would weigh. And he said, no, the software's the holes. You can try that, folks.
Are there more questions for the audience? Don't be shy. Hilmar, looking shy.
So I have a question. There is, for those in the US, of you in the US, you're probably aware of this NSF program that's called Advanced Biological Informatics, ABI, which is one of the main funding programs from NSF, rather from the NSF direction for bioinformatics tools of all kinds. And so it's traditionally been just one program, and that, as we all know, had a strong disdain, as NSF in general has, for funding, maintenance, and incremental improvement. And so which led to the perennial complaints that NSF keeps funding software and then closes the tap, so to speak, and upon which the software that they've just funded dies again. And so now they divided the program into different tracks, and one of those tracks is called, I just looked it up, it's called the sustaining track. Okay. And so it's specifically targeted at maintenance and incremental improvement of existing resources. And so I'm curious. So there's pretty high bar. It's not going to just fund any software project. It has to have wide significance for the community. I guess it has to have a very strong deletion phenotype, if you will. And so I'm kind of curious on opinions as to whether that's a solution or really has too many problems that come with it to be a real solution to the problem.
So my software was funded through the ABI program 4 years ago, and my program director strongly encouraged me not to apply again.
Say that again?
So my software, my project was funded 4 years ago through the Advanced Biological Informatics program, and my program director strongly encouraged not to apply again through the same program. Even though now you have the two tracks, he told me, go find money elsewhere. And one of the one of the programs that he mentioned at the National Science Foundation is the SSI, the Software Institute, whatever, I don't know what the other, Scientific Software Institute or whatever, which are potentially larger grants. But they are also more, then the challenge is that you need to build a case that the software that you're doing is really, as applications beyond, the biological directorate, which is not so easy to do. But the problem of maintenance, I think that all the software agencies are struggling with that. I mean, we have in the same institute, we have the lead developer for Copasi, which is a systems biology platform. And they went through a first phase of funding through NIH. I think it was 4 years. And pretty early on in these 4 years, they had a paper describing Copasi And I think that when they came up for the renewal, that paper already had 700 citations in a few years. So I mean that's definitely a software that has a user base that is necessary and things like this. They didn't make it through the first, when they came up for the renewal. I mean they got a very low priority score. They got barely scored. They somehow managed, and for really details. I mean people just. They just look at Google search, and based on the ranking on the Google search, they decided that the software was not worth anything. I mean that was as basic as that. So eventually, they managed to reply and eventually got funding. But for a software that has so many users and that such an impact, it's kind of a little bit embarrassing to think that funding is an issue. And so I don't think it's on the NSF. I think it's everywhere. They like to start stuff, and I think that the reasoning is that all the funding agencies, they want to do transformative science, and so as soon as you start coming back for a little bit more of the same, it's not transformative anymore. It becomes boring. So somehow you have to find a way of getting it funded elsewhere because you lose that cutting edge. I don't know. I mean that's just my take on it, but it doesn't sell. Maintenance is really hard sell.
I think the funding agencies are finding it difficult to put a value on the software that they're funding. They know they want to. They know that the infrastructure is important, but they don't have a way to say this is where we should put our money and this is where we shouldn't. I don't know too much about the NSF, but I'm still an advisor to HHMI, to the Genome Institute at NIH. And not exactly remembering the numbers, but I think it's on the order of about 30 to 40% of NHGRI's budget is going to informatics one form or another in terms of software and databases. And that proportion's been slowly increasing in a way that scares them because they could obviously spend more and more and more. This is a big black hole they could drop money into, and it's hard to know how to value the investment in computational infrastructure. So there's been a lot of discussion about how to set a value. And it's almost as if Genome is trying to reinvent a capitalist economy because it's like you want the customers, the biologists, to somehow declare we would rather have you put X amount of your money here and Y amount of your money here and none of your money here. There's just no way of rationally getting that kind of feedback. So the funding, at least in the case of Genome and HRI, they feel like they're fumbling in the dark. They don't get the kind of feedback that a real market economy would give them on what's valuable and what's not. They're trying to do it in a top-down planning way that makes them, that makes us crazy. Genome's program officers themselves feel a bit crazed because they don't know how to do this right. They know it's important.
And I think they look at simple things like download factors.
Yeah,
and I know I've certainly tried to help out several of the people in the room actually with reference letters or anything that I can do when I know they're coming up for funding because the software is important to my customers. So it's a nice feedback loop.
But another point, Sean, I think what NHGRI does, in my observation, is that once a project, be it a database or software, goes into a second cycle, it sort of becomes one of the preferred child. And then one of those, if you start supporting those and those support others, they sort of become sort of self-select in a way within the organization. I mean, not to hit on Galaxy, but Galaxy has become one of those children. And so supporting Galaxy, and if Galaxy supports you, it becomes a sort of a good thing. I mean, it's viewed well in my perception and declared conflict because I'm with you on the scientific advisory board for Galaxy. So, but it's definitely, I've seen it for other projects as well that are funded by HRI.
So when we come back to the stuck record, so publication, but actually other forms of publication. So, when you have something such as Galaxy, it's a great example because the NHGRI wants to return or wants to maintain its investment. And as long as people are increasing in their use and there's other projects feeding off Galaxy, that's a wonderful source. So if we expose ourselves to some of the activities of like SageFire networks and others where a particular pipeline or a set of steps can be published with a DOI, so somebody can potentially gain attribution, or at least that activity for the software and or the project can be attributed if anybody reuses it or cites it. Now that is a large project, but in any activity that can be done if there's a framework within which you can publish a BOI. And for new projects, it's great if you were able to, and do the same with the data release, if you were able to go to an agency and say, look, here, I'm on a trend here. This is a trend for this particular form of activity. Here's something worth investing in because we're already on the derivative, so we're about to uptick. We need to get on top of that loop with your investment. Because any investor wants to see the huge leverage of whatever they invest in, which is effectively what Galaxy has been. And I think our job is to make the argument to funding agencies that what we're doing is valuable. Now, all of us know that developing our software and or databases and data itself is a catch-22, because of course you have to get it in the hands of the user who actually wants it. And damn it, occasionally that's a biologist. And I mean, I was one once where I woke up, and the thing is that there you have a real challenge because you have to speak another language in order to make that effective, and that's incredibly difficult unless you understand what the user needs. And really, you have to listen to the users. So I think there's a lot of our responsibilities to listen to what our users and those whom we develop for, and at the same time, think carefully about how we're going to sustain what we're doing in novel ways, and then communicate that into funding agencies and or our philanthropists. Because often, certainly in the States, we're looking for philanthropy, we're looking for crowdfunding, any way to show that we're valuable.
Yeah, I don't know. Does anyone have tips or thoughts on how to? I mean, you guys are getting money, so how do you promote yourself in a way that makes you stand out over other people? I mean, you mentioned papers. Are there other sort of metrics or ways in which you emphasize the importance of software, or sort of work on your software in a way that I think people are probably looking for ways that they can get the most bang for their buck, I guess, right? So, I mean, you can write papers that the most bang for your buck is getting more users, or counting downloads it's the most bang for your buck. I don't know what's the sort of, what do you think the key things are?
So getting users, evidence is of all kinds is what you need, because if you approach it as a scientific activity, if you say, I make the claim that my software is used, where's your evidence? That's the first thing that any funding agency will want, because they cannot work without that. And that evidence can be downloads, which is a very rough and ready kind of thing, but actually real qualitative evidence. Like this project emerged because of our platform. This science was done because of this platform. That's but much harder, because particularly as software becomes fundamental, so for example with things like Python and so on, no doubt splendid science is emerging from it, which will never cite you because you're completely invisible. It's, because if you become truly successful, you become ubiquitous. This is a well understood sort of social phenomenon. In fact, Alvis recently wrote about it for Array Express, that something like only 30% of people who actually use and really get their scientific results from using Array Express actually bother to cite it in the paper. And so when it comes to, well, did anybody use you, then you haven't got the evidence. You have to go out and get your evidence. And then pick your battles, pick your allies. That you big groups that or important groups or up-and-coming groups that are using your work, that you can go jointly to funding agencies. So don't just go as e-infrastructure, go as a solution to something.
I think having little communities around software, you've actually done this a lot with Taverna and my experiment. Galaxy's done it as well. I think helps. You've got people who are already on your side who are using your software, leverage them.
Another thing is that it's really important to think about it at the beginning of the project, to start logging things, whichever type of logging you're going to do, and do as many different kinds as you want. It's not when you're writing the next grant that I should attract users. So you really have to think about it at the beginning and then do it. And you'll see which is the best metric to represent your community later on. It is a lot of work.
Cool. So I work on a cloud bioinformatics platform, and one thing that we try to encourage, and I think it's going to be really important for Galaxy to encourage, is
On the Galaxy Tools side, there's a review panel which is trying to review tools through the Galaxy Tool Shed, and one of the things we look for is the documentation shown to the user, which should include the citations that one would make if you used that tool. We've discussed on the main list an automated system where the tool author or tool wrapper author can mark up the desired citations so that when you run the Galaxy workflow or you look at your history, ideally one day you'd be able to say, give me the citations I should be sticking in my manuscript. That doesn't exist yet, but people say, yes, that's a wonderful idea. Would anyone like to write it, please?
That was more, so the question that was coming to my mind is there a place for a shared infrastructure that assigns DOIs, tracks usage, looks at GitHub and looks at users and followers and watchers, could potentially look at citations, but through aggregating attention by creating DOIs would therefore encourage a particular form of citation. It would be easier to track. I mean, some of you may have seen my tweet earlier today where I was joking about the fact that I looked at 6 papers with POS computational biology with Perl in and couldn't find the code at all, and then looked at 5 papers with Python in it and you could find the code in 3 cases. But in several cases that was, and we used Bioinformatics, link, not citation, link. And whether creating a service which somehow gathered people's attention, maybe did some of the things around badging, really high quality research papers that included software, could potentially create the kind of market that Sean was talking about. I mean, it's a community infrastructure that in the end will make some people and some projects look better than others and will help you to understand when some things should be sunsetted, which is part of the problem. But is there a value in building that up?
Maybe. I was thinking specifically of tracking DOIs for publications in the traditional sense, but maybe something like Figshare could be used to assign a DOI to a Python script. Like a gist
it would be very easy to set up a service to assign DOIs to software, to redirect to GitHub or wherever your documentation or your website is. That wouldn't be terribly difficult at all.
DOIs for repositories.
Yes, so this is actually being done in quite a few. So in our systems biology, the models are identifiers and people refer to them, and because they are commodities that have to track just as anything else is tracked. And in things like the GBIF services, you have to, if you're going to use those, you absolutely have to credit the collector of the data. Because somebody's dedicated their life to counting the number of butterfly occurrences in Guatemala. And so we need to give them some credit. So you're not allowed to use those services unless you've really tracked in the pipelines, did you touch their data? If you touch their data and it survives the results, you must cite them and you must give them credit. So in our pipelines, we should be doing that.
I've just had a book chapter accepted, which is talking about Galaxy workflows as a review chapter. And I'm going to put the DOI of that on the workflows so that people who use the workflows or a derivative of the workflow will hopefully cite that bit of scientific work, get some metrics on it.
Yeah, so we've done that in my experiment a lot. You know, that's why we built it. So you'd have IDs associated with things you can put, and you'd be able to track them and see, how. But people are very bad at doing it.
Yes,
there's a reciprocity contract that isn't followed for data and for scripts that is followed a bit more for publications. It's kind of the sort of voyeurism part of using infrastructure, that I want to be able to use all your stuff, but I don't actually want to be able to participate. So that's what we have to get over.
I want to introduce another topic kind of from the industrial perspective. I mentioned letters of support as a thing that we can do, but I think other ways that you can look to industry, and we're not necessarily all rolling in money as we maybe were years ago, but you can look to us, I think, in places to donate code. I've certainly tried to do that, especially if it's a bug fix. I know companies have done internships, especially if you can find something that's mutually agreeable, that's an extension of your software, that would be key at this particular company. See if they'll fund somebody internally to work on that for some period of time with the code being donated back. And another aspect of this is we also at times can help with testing, with documentation, sometimes with support. Certainly if one of our customers has a problem and it has to do with an underlying open source program or tool that we're using, our support folks will end up taking care of that. And other than maybe fix at some point. You probably never even know that there was a problem. So I think there's that aspect also that can come in from the industry. So.
Cool. Thanks, guys. Sorry, I think we have to finish now. But so just as like a wrap up, that was a great topic, and I appreciate you guys. That was awesome. And I think the one thing I learned, sort of as a wrap up from everything everyone said, is like that we have to be better as researchers and programmers at documenting and promoting the use of our work. So I know I'm awful at it, right? Like, I don't know, that's not my core value, but I mean, you should have a wiki page where it says who's using your software, what people are using your software, so someone can look at it and know who the users are, what value they're gaining from it, and try to emphasize that. I think is what everyone here is good at doing, and that's why they're getting money. And so if you want money too, you should do it as well. And that's what I learned from the discussion. But I really appreciate everyone doing it. Please give a round of applause for the panel.